Well, I'm going to introduce myself. Hi, I'm Pierre-Yves Ricau. I don't expect you to know how to pronounce my name, so you can call me PY or Pierre, and it's going to be fine. And I work at Square. And so tonight I want to talk about LeakCanary and memory leaks in general. Or tonight, I guess, this morning. The lights are making it feel like it's the night. So LeakCanary is an open source library, but let's talk about out-of-memory errors first. So who here had an out-of-memory error exception happen to them in the past? Yeah, pretty much everybody, right? And so what you're looking at here is Square Register. It's an app we built to take payments on your mobile device. And this is the signature screen where the customer signs with their finger. And if a crash happens there, an out-of-memory error happens there, then they have no idea if the payment went through or not. It's really bad. I mean, we are Square. We deal with payment. We deal with money. And if you don't know what's going on with the app, it really feels bad. So we need to take care of those out-of-memory errors. So before diving into a lot of technical details, and you'll see a lot of code in that presentation, I want to take kind of the higher level view by having a lot of images. So let me explain memory leaks. Let's start with, yeah, it's right here, right there. Let's start with my hand. So my hand, as you can see on that picture, will represent the amount of memory that we have in our app. So I can hold a lot of things in my hand. Like I can hold keys, I can hold an Android collectible, and let's pretend that my Android collectible needs readers to function like Square readers. If you look at the details, you'll see that the readers are attached to the Android collectible with some thin threads, and this is kind of the image for references. So my Android collectible needs a reader, and it's holding on to it. And so my hand, has a limited amount of memory, a limited amount of weight it can hold, and so all these readers attached to the Android collectible adds to the weight. So when I'm done with the Android collectible and I think I don't need that thing anymore, I just throw it on the floor, and my garbage collector collects it. And collects all the Android collectible and the readers, and everything gets into the trash, and it's amazing. And my hand is light again. However, sometimes something bad happens. Sometimes, say, my keys are somehow attached to my Android collectible, and they hold on to the Android collectible in a way that prevents it from being thrown on the floor and being garbage collected. This is a memory leak. Yeah, it's sort of. The thing is, so we actually talk about reference leaks. I'm going to simplify and call that a memory leak, but what's going on here is that there are extra references pointing to an object, and they shouldn't be pointing to that object, and it prevents that object from being garbage collected. Now, all these small memory leaks, they accumulate, and all these tiny threads just add weight to my hand until the hand crashes, and it's just too heavy. And that's where LeakCanary comes in. So LeakCanary, what is it? It's the idea that this Android collectible, at some point, as a developer, I know that I want to get rid of it. I know that it should be destroyed and garbage collected soon. So I attach some sort of smart pin to it. And I promise, we'll get to the technical details later. This is a bunch of pictures, but it should be more technical at some point. You'll see. Anyway, this smart pin is really smart. It knows when it's being garbage collected. It knows when it's in the trash. And so what happens if after a while it realizes that it's still not in the trash, it takes a picture of the memory, and that picture is basically Heap Dump. So it's basically taking all the memory and putting it on the file system. And then LeakCanary publishes the result, which shows the chain of references that are holding the object in memory and preventing it from being garbage collected. Now let's get to some real details. First of all, if I have enough time at the end of the talk, I'll have questions, but I'll try something new, and we'll see if that works. If you have questions, you can post them on Twitter on hashtag LeakCanary. That way, I can avoid the embarrassing questions. It's good for me. And if you're too shy to ask a question, you can just post it on Twitter. It's going to be fine. And I will answer them offline afterwards as well. So let's come back to our crash. That's an out-of-memory error, right? Why do we have an out-of-memory error? We're not sure. What are we looking at? We're looking at a screen where we can sign with our finger. So it's basically a giant bitmap where we hold the signature. And it's the size of the screen. This is sort of the view hierarchy. As you'd see it in 3D, this is like a library that Jake Wharton made that's called Scalpel. It's cool. It's not that useful in general, but it's kind of cool. But the thing that's interesting, it shows the view hierarchy, and that's a side note. We have a very deep view hierarchy, and that's terrible. If you want to know more about that, Logan Johnson is giving a great talk about forestry and other things tomorrow, and he'll talk about that. Coming back to the out-of-memory error, we have a stack trace. And so, we think we're smart. We look at this and we're like, oh, the bitmap must be too big, so what can we do? Well, every pixel is only black, is only basically a shade of gray, right? It's from white to black. So we don't actually need all that color information. So we switched the configuration of the bitmap to alpha 8, thinking, oh, that's going to save memory, right? So it's going to help us. And I mean, who's been trying to kind of like reduce the size of bitmaps when you get out of memory errors? I mean, it's fine. Everybody does that. That's kind of expected. You're like, my bitmap is too big. I'm going to reduce it. Then we tried something else, which this one is okay-ish. It still makes sense. The next one is crazy. Let me walk you through it. So we try to create a bitmap in 1. And then if there's an out-of-memory error, we catch it in 2. And then we try to do a GC. We just kick the GC. And then we wait a little bit, because you need to give the GC a little bit of time. And then we try again. And again, and again, and again, like maybe 4 or 5 times, until at some point we give up and we say, okay, sorry, we couldn't do anything. That's terrible, right? And no one should do that. We tried anyway. We were like, hey, might as well try. It's worth mentioning that, well, I'm the one who wrote that, and I feel bad about it. But I took inspiration from the Android AOSP keyboard. If you look at the source from at least 2 years ago, it used to be in there when it tries to inflate the keyboard the first time. If it doesn't manage to do it, try it again. So, I got inspired from somewhere else. Anyway, what's the actual problem? The actual problem is our heap is almost full, and we're trying to create a big bitmap, but there should be enough space for that bitmap. And there is not, because our heap is full because we have memory leaks. So all these leaks add up and they take all the memories, so we need to fix them, right? So what's a memory leak? Let's say that I have a baguette app that lets you buy a baguette in 1 click. So it's a pretty amazing app. I think only French people would really need that kind of app, but hey, I'm French, by the way, if you hadn't noticed yet. But say that I put this button in a static field for whatever reasons. The problem with this button being in a static field is it's never going to be garbage collected because it's in a static field. So until I set that field to null, the button will never be garbage collected. Now, you could say, well, it's just a small button. Who cares? The problem is my button has a field called mContext, which is a reference to the activity. And then the activity has a reference to the window, which has the entire view hierarchy, including my huge baguette picture in memory. So that's a couple megabytes that are held by just a static button, even after the activity has been destroyed. So this static field is called a GC root. What's a GC root? It's basically, so anything that will not be garbage collected. So the garbage collector tries to collect everything that is not a GC root and not held through references by a GC root. So you create an object, you remove all references to it, it's going to be garbage collected. But if you put it in a GC root, namely a static field, local variable on a live thread, on a stack, or a live thread, or a native global, all of these are GC roots and they don't get garbage collected. So that's great. The problem here is, so we look at this and we're like, well, it's obvious the button has a reference to the activity, so we need to clear it. But when you're in your code, you don't know that. You only see references forward. You see that, okay, I know the activity has a reference to the window, but who has a reference to the activity? You can try to kind of move around the code and use IntelliJ to do smart things, but it won't tell you everything. Because this is basically, you can think of the objects and the references as a graph, but it's a directed graph and it only flows in one direction. So, what do? We take a photograph. We take all that memory, we dump it to a file, and then we open it with a tool to analyze the heap dumps, to parse them. So one of these tools is Memory Analyzer, also known as MAT. It basically has all the live objects. The heap dump has all the live objects and the classes that were in memory when you took the heap dump. And this is kind of not very useful. Like, okay, I have like 3,000 objects or whatever. What can I do with that? Well, it has a query language, so you can actually write something that looks like SQL. It's called OQL, and you can say, give me all the instances of activity where destroyed is true, and it gives you all the instances. And then once you have that, you found the leaking activities, you can do something that's called compute the shortest path to the GC roots. And it will find the backward path to the objects that are preventing your activity from being garbage collected. You might notice or realize that I mentioned shortest paths because there are multiple paths from a GC root or from a number of GC roots to an activity or any object. For example, here my button also has a parent view, and this parent view also has an M context field. So, but when we look at a memory leak, we don't need to look at all the paths. We just want one. And using the shortest one is basically having the least amount of information, which means it's less noise. So it makes it easier to find the problem. So that's great. We know the tools. We've seen how we can take a heap dump and move around and find the cause of the problem. Now the problem is we can't really take a heap dump in a live app. We can't ask our users to go and plug in and do ADB and do all these commands and then send us a 70 megs file. We don't want to do that in the background. That wouldn't be nice. Some people do it, but that's not cool. So let's not do that. How can we detect the leak earlier as we are developing the app when it actually happens? Well, that's what LeakCanary is about. Think about an activity. It has a life cycle. You know when it's created, you know when it's destroyed, and you expect that after undestroyed is called, it's going to be garbage collected soon, right? So if you had a way to detect if it's actually been garbage collected, then you have a trigger for saying, hey, it's probably time to look into what's going on because this thing might be leaking. It hasn't been garbage collected yet. So activity is also nice. It's used everywhere because it's a God object that has access to all these services and and the file system and all that, which means everybody's using it, and which means there are a lot of chances that something is leaking it somehow. If an object is leaking, usually that object has a reference to a context and therefore leaks the context. So let's come back to our smart pin. When the lifecycle ends, we want to know about that and track what's going on. So LeakCanary has a simple API. The first thing you need to do is build a ref watcher, and it's basically just an object to which you're going to pass references, or you're going to pass instances, and it's going to make sure or check if they're being garbage collected 5 seconds after, right? And it works with any object, not just activities. Then the second thing we do is we listen to the activity lifecycle. So that's on 1. And then when undestroyed is called, you can see on 2, we pass the activity instance to this ref watcher. All right, so how does that work? Let's take an aside and talk about weak references for a while. So I mentioned how we have a static field that holds a reference to our baguette activity, right? And that's done. So by now button, the button has an M context field that's the context, and that's keeping the reference to the activity. That is called a strong reference. And the way garbage collection works is you can have as many strong references to an object as you want. But when that gets to 0 and no one is having a reference to that object, then the garbage collector can claim it. A weak reference is a I guess you guessed that, it's different from a strong reference. And the idea with the weak reference is it's a way to access that object without increasing that counter of number of reference to it. So if there are no more strong references to that object, then the weak reference is going to be cleared. And that is perfect for us because we just take a weak reference to our activity, and then if at some point we realize that the weak reference is cleared, it means that the activity has been garbage collected. If it's not cleared, then it's likely that there is a leak. We don't know yet, but it's very likely, and we need to investigate. And weak references are very useful for caches. That's usually their main purpose. There are a few other things you can do with them, because it's basically a way to tell the GC, oh, can you keep that in memory? And if you really need to, you can clean them if no one else is using them. So we extend weak reference, and in one you can see that we add a key to our weak reference. That key is going to be a unique string, and the idea is that when we parse the heap dump, then we can ask for all the instances of keyed weak reference, and then we can look for the one that has the corresponding key, so it's very easy for us to know what we're looking for. So then when we call watch and we pass it a reference to watch, what's actually happening is, one, we create that weak reference, and then two, we say, later I need to check the weak reference, and later being in a few seconds. What we actually do under the hood is called system.gc, which again, no one should do, but it's kind of a way to say, hey, garbage collector, now is a good time to clear all the references, and then we check again. If it's still not cleared, then we might have a problem. So we trigger the heap dump. All right, so now we have a heap dump. It's amazing. What can we do with it? So originally, we would do that, and then I would manually download the heap dump file and open it in memory analyzer. And I realized, I showed you, what we do, and I realized that I was always doing the same thing. Every single time, opening it, finding the instance, computing the shortest path. And I'm lazy. I guess we're all lazy, right? We're developers. So I don't want to do the same thing over and over again. So I looked into what I could do, and what I could do was writing a plugin for memory analyzer. A plugin that means an Eclipse plugin. And I don't want to do that. It's crazy. An Eclipse plugin, no one should ever have to write an Eclipse plugin, like ever. It's terrible. So I decided to not do that. But instead I realized I had a haha moment, I had like, oh, I don't need to write an Eclipse plugin. I just want to write some sort of code that's going to do that for me. Actually, ideally, I would take what's in Eclipse and remove the UI and then use the rest of the code. So that's haha. Headless Android heap analyzer, which is basically a repackaging of some code written by other people. Yeah, the name, I'm pretty proud of the name. Sorry. And so it was a fork from 4 years ago. Someone forked memory analyzer and removed the UI. And then 2 years later, someone else forked that and added support for Android. And then 2 years later, I found it, and I just repackaged it to put it in, in Maven Central. And I recently changed the implementation to, instead of being based on memory analyzer, it's based on the new code that's in Android Studio. So you might have noticed that you can now have some memory analyzing. I guess you have some Heap Dom Parsing tools in Android Studio, and it's basically a different code base. It's called perflib. So I just took that and used that instead because the code is actually decent and is going to be maintained. So I really love that about it. Because I don't want to write a Heap Dom parser. I'm lazy, so I really don't want to write anything at that point. So we have our library to parse heap dumps. And basically then it's very easy. We open the heap dump, we load it, and we parse it. And then we find our reference based on the key that we had. We obtain that instance, and then we just need to parse the graph of objects and walk backward and find the leaking reference. All that work is actually happening on the Android device. So what's going on is when LeakCanary detects that an activity has been destroyed but not garbage collected yet, it forces a heap dump that gets put on the file system, And then it starts a service in a separate process, and that service is going to start to analyze the heap dump and publish the results. And that way, because the problem is if you were in the same process, then you might run out of memory trying to analyze the heap dump. So it's kind of a weird, like, recursive situation. And so that gives you this. It's giving us a, at the end, it gives us a notification, and then you click on it, and you get an activity that displays the chain of references for your leak. It also can show the size of the memory leak. So you know, like, oh, this activity that's been leaked actually holds 4 megs of memory, and I could claim that back if I fix the memory leak. The other thing is the API is extensible, so you can have hooks and callbacks. For example, you could upload all that information to a server. We didn't do that. Again, laziness. Instead, we just used the Slack API to upload that to a Slack channel, because this is a developer build, so it doesn't really matter. So in one, you can see how we do that. It's like one, like defining, using the Slack API is actually really easy. All I did was create an interface, put a bunch of annotations. I used retrofit. By the way, Jake is going to talk about retrofit too. Yeah, I know I'm advertising like all around, but great talk. And then two, in the channel, we get all that information about the memory leak. So this has enabled us to lower the crash rate by 94%, which is huge. I can't, so you're like, yeah, this is a great graph. There's no axis, right? So I could be whatever. I mean, I could show any random number. The thing is, I'm not allowed to show numbers because it could give you, insights into our user and this kind of thing. And so, just trust me, it's good. It's really good. All right. So we have LeakCanary. It works great, at least for me. I hope for you too. Let's look into a real-world example. A memory leak that we found in AOSP, so in the Android source code. And I don't want to point fingers at Android at all. It's just that if I was to show you like my own memory leaks, you wouldn't care because, and also, we don't write memory leaks because we're really good, right? So I don't have any actual example. No, that's not true. But basically, I think it's more interesting to look at an Android one. So let's say we have an app with an undo bar, right? And it doesn't actually matter that much, but it's nice to have a nice screenshot. So we have an activity, and then at some point you click on a button, and we want to remove the undo bar, right? It's pretty simple. I don't think this code needs like a lot of explanations. Let's look at what happens. So, we get all the views, and then we do some weird stuff here where we set a layout transition on the undo bar. We add a view to the undo bar because why not? We want to, so it's cool. We can do that. Nothing should prevent us from doing that, right? And then we remove the undo bar from its parent layouts. So at that point, nothing's referencing the undo bar anymore, so it should be garbage collected soon. And if not, then we have a problem. So we want to check that. So we use the LeakCanary API to say, hey, this undo bar should be garbage collected soon. Please check that in a few seconds. So we do that. We run the app. We remove the undo bar, and we get LeakCanary isn't happy. It found a memory leak. So what's going on here? And this is going to be a bit tricky, so we'll see if I can explain it right, and otherwise, it's okay. But let's see. So on one, you can see that basically we have, so input method manager has a static reference to the current root view. And that current root view, it's actually fine. That current root view is currently active. It's the thing that holds everything. And so it's okay. This one should still be here. But then the root view has a thing called a tree observer. And the tree observer is an object to which you can add listeners so that you can react to changes in the view hierarchy. And that's unique per view hierarchy. And so that tree observer has a bunch of pre-draw listeners. Pre-draw listener, you add a pre-draw listener, and then it's going to get called back right before drawing the view hierarchy. So again, that seems fine so far. Yes, the view tree observer has a bunch of pre-draw listeners. Now, one of those pre-draw listeners, though, is a layout transition $1, which is the Java way to write the names of anonymous classes. So this means this is the first defined anonymous class in the layout transition class. And then you see that it has a field called val$parent that references our leaking frame layout, our leaking undo bar. This field, val$parent, is basically a local variable, a final local variable outside of the anonymous class that's called parent. And that's how the compiler changes this syntactic sugar into something that's compatible with Java 1, basically. So like everything is compiled back to borrowing all classes. So let's look at what's going on. And this is Android code. Layout transition is an Android class, right? So we find the anonymous class and where the pre-draw listener is added. So observer here is a view tree observer. And everything looks really fine. So it's like registering a view tree observer, and then on the first callback, it immediately unregisters itself. So we shouldn't be leaking, right? That sounds wrong. And at first, I was like, something's really, really weird. What's going on? Why would that not work? Well, let's look at get view tree observer. So get view tree observer returns the view hierarchy view tree observer if attached. If the view is not attached, it returns a temporary view tree observer that will, when the view reattaches, everything that's in there will be merged into the live view tree observer. So the thing with that is, if my view is detached, I'm going to get a fake view tree observer. I'm not going to get the live view tree observer. Now, if you look at 3, we set the layout transition, and 4, we add a view. So this triggers the add on pre-draw listener in the layout transition. So now we have a pre-draw listener registered on our view tree observer. But then in 5, we remove the undo bar. So the undo bar is detached and doesn't have access to the view tree observer anymore. And so green here is the current state. If you look at the current state, it's basically asking the view, which in that case is detached, for the view tree observer. So it gets a fake view tree observer, and it can't remove itself from it because it's not in that fake view tree observer, it's in the real one. This change here was done actually 4 years ago to prevent another bug. This bug will be fixed in a future release. So it's been fixed in Android, but we don't know when it's going to be available. The problem with that is I thought really hard about that, and this memory leak that exists in Android, there is no way around it. We don't have any way to prevent it. It's just there. So all we can do is just wait like 5 years, and maybe we'll be fine. So, go on vacation for a few years or something. So, but in general, the problem is there are some memory leaks that we cannot fix. So we don't want to look at them. So what we did in LeakCanary is have a way to, once we parse the heap dump and find a memory leak, ignore some of the leaks so that we don't get bothered by them and we can focus in our own problems before yelling at the Android developers. Like, you first, and then you can clean up everybody else's house. Like I say, it's a dev tool only, and you obviously don't want to ship that in prod. You don't want to show. So what it does is it shows a canary and then shows a notification. You don't want to do that for your users because that would be really weird. And it's great to detect memory leaks early. The problem, though, is sometimes you still have out-of-memory errors. Like you show the graph, and this number here that I can tell you is still greater than 0. So is there something else we could do? And I just want to take a minute to talk about the future of LeakCanary. So what if, instead of doing all that stuff in dev, we were to release an app, and when there is a crash, we look at the crash, and if the crash is an out-of-memory error, then we do the same sort of thing. We take a heap dump, we start analyzing it in a separate process, and then we're not looking for one single leak anymore. We're actually looking for, give me clues about what's going on. So this is thread uncaught exception handler, so you can set that, delegate to the default one, which is going to crash the app, but before that, take a heap dump, and then start another process. What's interesting here is that we can then do something like list all the activities that are destroyed and then find why they're still in memory. And then list all the views that are detached and these kind of things. And that would help us like find, and because we know the size of everything that's kept in memory, we could even prioritize and say, hey, this one's more important than that one. So you could imagine a tool like Crashlytics or some like crash reporting tool having an extension for this kind of thing and having a server from that. And so I on the plane recently, I actually wrote all that code, so I have like a proto of that, but it's not released yet. And it's not really releasable. There's a lot of things like, I don't know if that's going to work. One of the biggest problem here is you're running out of memory, so it means there's a lot of stuff in memory. So when you're going to parse the heap dump has everything that was in memory. So if you're going to try to parse it even in another process, you're going to reach like the kind of maximum amount of what's in memory. So we need to change the way we do things to like have a streaming approach instead of just loading everything in memory. So that's all I have. So let's try. I don't know if that's going to work, but if anyone has questions, I hope you posted them on hashtag LeakCanary. I'm going to switch and try to load that right now. There's my email, so as you know, everybody here, Square is actually hiring. How surprising. And you can send me an email, and I'm not getting any money from that, I promise. So you don't have to, but if you're interested, you can send me an email, and the other thing is my Twitter handle. Let's see if we have. So how do I do that? I guess I'll just read them. All right, no, took. I'm trying. All right. Okay, so I have a question. Any idea whether or not LeakCanary works with Kotlin-based apps? Well, the answer is simple. I don't know. But I don't see why not. In the end, it's all bytecode, and Kotlin has references too, so you should be able to make it work with LeakCanary. I have another question here. Do you have LeakCanary activated all the time on debug builds, or rather enabling it for some builds just to test it? So different people take different approaches. What we do is it's enabled all the time. The problem with taking a heap dump is that it freezes the VM, and so when you're trying to QA the app, and there's a leak in the middle, well, you want to know about leaks, but sometimes you just like want to be left alone and like you don't care about it. So it's very easy to disable it, and we sometimes do that, disable it in some builds. Generally, though, as soon as you start providing that, people will disable it, and nobody's going to start looking at it anymore, and then it becomes useless. So it's kind of a balance. I would say fix the memory leaks, and then you won't have any problem. But I would be lying because you still have the Android memory leaks, and these ones are still going to happen. So it's a balance. We try to do it as much as we can and fix the important leaks. And that's all I have for now. We have 3 minutes left, so if anyone has any question, you can raise your hand, and you can. I don't know if there's a mic, but if you don't have any question, you can go and enjoy the breakfast and the next talk. Thank you.